Good morning, everybody, and thank you for being here. We know that LLM models are everywhere right now, and lots of companies are building their retrieval-augmented generation systems behind the scenes. But to fully understand how retrieval-augmented generation systems work and to build some trust in them, we will need to do some evaluation properly. And that is why I'm standing here to talk to you about evaluating RAG systems. So something about me. My name is Yue. I'm a machine learning engineer at Modulai. And before Modulai, I was doing my PhD at KTH on breast cancer risk prediction using AI. And at Modulai, we are specialized at AI and machine learning consultancy, delivering end-to-end solutions across various industries. We are headquartered in Stockholm, and we also have our offices in Gothenburg here and Basel in Switzerland. In today's talk, I'm going to begin with a brief introduction to RAG systems, and followed by why evaluation is important and what challenges it presents. And then I'm going to walk you through two approaches to do automatic RAG evaluation. And then I will share some insights from real-world projects. And in the end, I will wrap up with some practical recommendations. So we all know that the standard chatbots can answer questions like, can cats eat chocolate? This is not hard because LLM models have already been trained on this information, because this information is publicly available. But what if I want to ask a more specialized question, like, what is my cat Chi-Chi's favorite candy? Do I think the chatbot can answer this question? I don't think so, because this information only exists in my head and my family's head. And that is where a retrieval-augmented generation system can come in. So retrieval-augmented generation systems, also called RAG systems, they consist of two main components, a retriever and a generator. The retriever searches an internal database. In this case, it could be a database that I kept some record of Chi-Chi. It fetches some relevant document parts. And then this LLM generator uses both the retrieved text and my original question to generate a response. And why do we want to do RAG evaluation? Evaluation is important because it measures system quality. By looking at your evaluation scores, you can keep track of your RAG system's performance and make sure that your system is performing as expected. And also, it can inform decision-making, helping us identify areas for refinement. And having some poor evaluation is really risky because it can lead to bad business decisions. So we want to put some effort in RAG evaluation. Is it easy to evaluate a RAG system? I would say no. And there are a few challenges. The biggest challenge, I think, is that this RAG field is so new, and there is no established standards yet. And also, public data sets are quite limited. Most of them have already been included in LLM's pre-training data, making them very dissimilar to how a RAG data set would look like in real world. And this makes the development of RAG system evaluation even harder. Before we start looking at RAG evaluation approaches, I would like to raise a quick disclaimer. So Pydantic AI has written this down on their official documentation, saying that anyone who claims to know for sure how your RAG evals should be defined can safely be ignored. But I'm not saying that you should ignore the rest of my talk, but I do want to clarify that like the aim of this talk is not to give you definitive answer or give you perfect RAG evaluation framework recommendation. Instead, I would like to use this as an opportunity to spark ideas, to show you what approaches exist, and hopefully you can like know how to improve your RAG evaluation and use or adapt the existing approaches to your own use cases. All right, finally, the actual approaches. I would like to start with the most straightforward approach, end-to-end LLM judge. So let's revisit this like RAG pipeline. So we have a retriever that fetches relevant documents. And in the example of Chi-Chi, if I ask a question, what is Chi-Chi's favorite candy? The retrieved document could be like, Chi-Chi is very talkative. She always meows until she gets this freeze-dried tuna. And this could be the retrieved document. And then the generator, the LLM generator, takes this retrieved document and then generates some response. So we can see that there are two components, retriever and the generator. And we can evaluate them separately, and we can also evaluate them in a combined way, and then we can do some end-to-end evaluation. But on this slide, we are only evaluating the performance of a retriever. And the method is very simple. You just use an LLM judge. You just write in your prompt. So you're an expert in evaluating the retriever. And here's the question, what is Chi-Chi's favorite candy? And here's the retrieved context. Chi-Chi always meows until she gets this freeze-dried tuna. And you ask the LLM, is this context relevant given your question? You can say, give me a binary score to indicate how good the context is, or you can also instruct it to give a score between 1 to 5. It's also possible to evaluate the generator. So you do something similar here. You give your response together with the retrieved context with this to this LLM and ask it, is the generated answer faithful to the retrieved context? And this measures the answer faithfulness. And you can also evaluate the retriever and the generator all together by giving all those 3 gray parts to your LLM and ask, is the answer generated relevant given the query and the retrieved context? We can take this step even further. So instead of relying on off-the-shelf LLM models, you can also fine-tune LLM judge on your own data. And this means that you actually need to create some labels. Say, okay, this response is good and this response is bad. But then manually creating labels is quite time-consuming. So what you can do instead is to generate synthetic data. And here's how it works. We start from document chunks that can be retrieved by your RAG system. And then we ask LLM to generate synthetic query. So basically, we ask LLM to give us relevant or interesting questions that can be derived from the document. And then we use LLM to generate synthetic response, giving the synthetic query and document chunks. After the synthetic data is ready, we can fine-tune LLM judges. And for training different judges specialized for different metrics, we give them different data sets. For example, this framework called ARAS, they train a judge for answer relevance by asking the model to distinguish good synthetic responses from the bad ones or mismatched ones. And this kind of fine-tuning is very valuable because it makes you get more reliable judge that is better suited to your data. And then the next approach I would like to touch upon today is this claim-based multi-step evaluation. This is an approach that breaks down the evaluation into 2 distinct steps. So the first step is to extract claims from the RAG system's generated response and the ground truth answer. So what it does is that we use LLM to break down responses and ground truth answers into the smallest statements possible. And then the next step is to do some claim cross-checking with the help of LLM. And this part I will detail later. And with this detailed 2-step approach, we can derive many metrics, such as factual correctness, context precision, recall, and faithfulness. And this slide tells us how the claim breakdown works. Let's say I have this question. When was this company founded? And where is the headquarters location? And we get the response. And then we can break this response down into 3 different claims. Not we, LLM breaks the response down into 3 different claims, covering 3 different aspects. So we can see one claim is about the founding year, one claim is about the founder's name, and then the third one is about the headquarters location. Now, after the claims are extracted from the responses and ground truth answers, we can compare them and see how much they are aligned. And this will lead us to get a score called the factual correctness that measures the system's performance end-to-end. And we can get metrics like precision, recall, or F1. For example, the recall is calculated by looking at each claims in the ground truth answer and see whether they can be found in the response. And this kind of factual correctness calculation is done in different RAG evaluation frameworks, such as RAGAS and RAG Checker. And we can also evaluate the performance of the retriever by comparing the claims extracted from the ground truth answer with the retrieved context. So the idea here is that we will want to have all claims in the ground truth answer available in the retrieved context, because you want to have a complete retrieved document that can be used to generate the answer later on. And then we can get context precision recall. And now we can also evaluate the performance of the generator by comparing claims extracted from the response with the retrieved context. So this part, we want to evaluate whether the generator is hallucinating from the retrieved context. So ideally, we don't want the response to have some claims that are not available in the retrieved context. We can get faithfulness score by using this formula. Now let's compare those 2 approaches. So this end-to-end LLM judge is a simpler approach. It evaluates the RAG system holistically. But the problem is that it is really hard to score something granularly. Even for us humans, like giving a score between 1 to 5 can be tricky sometimes. And it would be easy if we can ask the LLM judge to score in a binary way, giving a score of 0 or 1, but this is also less informative. Let's say you have 2 responses, both have LLM giving a score of 1, and how do you know which response is better or not? We can potentially get a probability score between 0 to 1 by fine-tuning an LLM judge, but this requires extra effort. And on the other hand, the claim-based multi-step evaluation, it is more reliable because it breaks down the evaluation process into smaller steps. But the downside is that it requires managing multiple LLM steps, which is complex and time-consuming. Now, what about evaluating our evaluators? So it's not about evaluating our RAG systems anymore. It's about evaluating how good our evaluation is. And this can be done by calculating machine and human agreement. So after LLM, our evaluator, like automatic evaluator, gives us a score, we can compare like this score with human evaluator score and see whether they agree with each other. But then here is a very important prerequisite, which is that then we need to collect the human judgment score, which could be time-consuming. All right, and this slide shows us how we can apply RAG evaluation in our real-world projects. So we always start from collecting user questions. We want the questions to be relevant to users. And then we pass those questions to RAG system. We get the retrieved document, the generated response, and then we give the question, document, response to human expert. And we ask the human expert to give us a ground truth answer for each of the questions. And then this ground truth answer can be combined or compared with the generated response, and then we can get a factual correctness score with this claim-based approach I just talked about. And and apart from the ground truth answer, we can also ask a human expert to give us some judgment score, a binary score, whether they think this response is acceptable or not. And together with the judgment score, we also ask domain experts to give us some critique, explaining their reasonings, why they think this is a pass, why they think this is not a pass. And one thing we have noticed in this process is that human experts don't always know what kind of critique is helpful for developers when they are improving RAG systems. So there we need a few iterations to make sure that the domain experts know what kind of critique is directly actionable by developers. And another thing is that there's some ambiguity around what is considered to be a pass and what is not between domain experts. So we need a few iterations there to make sure that we are aligned with the standard. And after a few iterations, we can calculate this pass rate by averaging the human judgment for each sample across your data set. And from the previous diagram we saw, we included human domain expert, and we asked them to give us ground truth answer and human judgment and critique. But one thing I would like to highlight here is that their time, expert time, is quite valuable, so we need to use them wisely. And if you're wondering when you should collect ground truth answer and when you should collect human judgments or critique, here's a little cheat sheet. So if you want to have a benchmark data set for long-term reuse, having something reliable and repeatable, then you would need to have ground truth answer. And if your business cares a lot about the actual correctness, then you cannot get away from not having ground truth answer as well. You can potentially get this answer relevance, as we showed before with the end-to-end LLM judge, but considering something is relevant is different from judging whether it is correct or not, because a response could be relevant but still wrong. And if your business cares a lot about the quality of the evaluation, then you would need to collect the human judgments to do this agreement score. And if you can get domain experts to give you some nice critique, that would be awesome, because then those critiques are directly actionable and you can use them to improve your RAG systems to find areas for refinement. And then lastly, if you want to train an LLM judge, then you also need human judgment. We talked about generating synthetic data sets, but that's mostly for training. If you want to have proper validation testing, you need some golden standard judgments from humans. All right, and almost there. To wrap things up, I would like to leave you with a few recommendations. So first, RAG evaluation is really important. This is a growing field with lots of unanswered questions, but do not overlook it. It definitely needs more research and exploration. And second, start simple. If you're unsure where to begin, having an end-to-end evaluation is often the best starting point, unless your business suggests something else. And thirdly, involve end users as much as you can, because they know how to evaluate your RAG systems. And you want your machine evaluators to be aligned with their standards. And this also helps ensure real-world relevance. And in the end, automate whenever possible. You can have this automatic RAG evaluation in your CI/CD pipeline and make sure that you always look at numbers and catch issues early on, if there are any. And thank you very much. And I would like to hear your thoughts and comments and answer any questions you may have.
Thank you so much, Yue Liu. And this was great. I'm actually working with this right now. Not, yeah. Do we have questions right now from the audience? Because otherwise I'm gonna take. Okay, I can see a hand there. Can somebody help me with the microphone there?
Middle.
Thank you for the talk. I was just wondering, how do you approach the problem of suboptimal retrieval? So let me explain. You evaluate the quality of the retrieval given just the piece of information that you retrieved, but you may have something better in your database or whatever knowledge base you have, which would provide a richer and better response. So how do you evaluate that problem?
Yes, and this claim-based multi-step evaluation can actually solve exactly what you're looking for, because then we are comparing the retrieval output with the ground truth answer. And so if you have something that is better than what is there in your retriever's output, then it should be presented in the ground truth answer. And comparing those two can help you measure like the retriever performance better than using the LLM judge directly.
Okay, so you basically mix two data sources. So the ground truth is also what you have like for tests.
Yes, ideally, if you want to like always make sure that you are evaluating whether your retriever gets the best answer possible, then you will need ground truth.
It seems a bit biased, but I understand why you would do that. Okay, thank you.
Thank you very much. Maybe we have time for, if it's a very quick question, we have another question right here in the front. Can you please raise your hand again? Otherwise, they cannot locate you. This is a big room.
Thank you. I have a question from the same slide. You are talking about a multi-step evaluation. Isn't it better to have in the initial, let's say, the evaluation, go with the end-to-end, and after that, go with the fine-tuning, instead of going with a little bit complex, let's say, the architecture?
Sorry, I don't think I understand. Can you please repeat it?
We can do the evaluation in an end-to-end level and see that if it works with a RAG or not in a way that we are happy with it. If it is, the answer is no, instead of going with this multi-step evaluation, we can go just directly for fine-tuning based on our data.
Yeah, I think, yeah, it's always better to start with the end-to-end evaluation, but then there you will need to do, to compare your response with the ground truth answer to get the actual correctness, if that's what your business cares a lot about. And then if something, if you don't feel happy about it, then you can do evaluation of different components, the retriever and generator, and see what you can act upon. Does this answer your question?
Thank you so much for this. And please receive a token of our appreciation. Can we give a round of applause to Yue Liu?